Hey everyone, welcome back to the podcast. I'm your host, Haris Iftikhar, and I'm with a very talented individual named Saqib. He works at a big tech company, and he works in the hardware design with the AI edge, and he's a very talented senior hardware design verification engineer at Microsoft, and he's particularly on the AI Silicon Team Lab, and he has a great background in electrical and computer engineering. And he's currently working with AI chip technologies at Microsoft. So I'm super honored to have him on the podcast, and excited to have some fun conversations with him. So Saqib, the floor is yours. You can introduce yourself and a little background.
Awesome. Hi, everyone. Assalamu alaikum and greetings to everyone. Welcome to the podcast, new episode here, it looks like. I'm honored to be, greeted, and thanks for the rundown by Harris here. Thanks for the outreach. Glad to share context about my career and upbringing and just life in general.
Hmm.
So I'm based in Austin at the moment. I
Hmm.
do work for Microsoft.
Yeah.
I'm on the Silicon Hardware team for a team called Sky. It stands for Silicon Cloud Hardware Infrastructure and Engineering Team. So all in all, it's just a fancy term for I support the Azure ecosystem.
Hmm. Amazing.
Uh, and I've been working on their Azure Maya program. It's known in public. It's basically an AI machine accelerator. The Maya 100, I did have contributions on as well since I joined in 2020. I grew up though in Toronto, Canada for the most part. That's home sweet home, but I was born in Bangladesh. I also lived in South Africa for a little bit
Oh wow.
and California as well for a few years until I made my way here for just the longevity and sustainability of things here in Austin. So now I go back and forth between California, Austin, and Canada, and try and survive.
That's a amazing backstory, and just like the origin, the early career, like your personal background, like what inspired, Saqib to enter this field?
Yeah, that's a good question. I mean, I studied actually at the University of Waterloo, and I did electrical engineering in undergrad. I was a class of 2014, and I also did graduate school. So that was class of 2016. That was in electrical and computer engineering. Now, obviously, that's I've got some years on me. It's not like I finished school yesterday. I've got
Yeah.
some, some years on me, some age on me. I think what really made the difference on my end for something that's more of a hardware centric role was in my fourth year of undergrad. I took a digital circuits course. I learned about digital fundamental logic, sequential logic, combinatorial logic, and gates, or gates, and things of that nature. But not only in the basic level, to see how that is translated from schematic to actual synthesized version of chips and whatnot. I
Hmm.
really enjoyed that sort of process of you know, structurally coding some sort of hardware descriptive language, synthesizing that into a schematic, and then having the schematic ultimately be the blueprint for what is going to be manufactured, or what is going to be taped out essentially. So we had a kind of end-to-end exercise or a project in that fourth year course, and I was intrigued by it because up until then, for the most part, honestly, I wasn't hardware wasn't really in my radar. It
Yeah.
was more, I was doing a lot of internships and mobile apps, a lot of software centric
Hmm.
related work. So I would work on, Android development, iOS development,
Yes.
use a lot of Javas and Objective C at the time. I think now it's Swift.
Yes.
And I did Web OS. So I did a variety of software related roles and internships, mostly in Toronto. But I think what was a turning point for me was, I was going to school and I wasn't necessarily fulfilled by that line of work. I got my feet wet in the internships with the mobile app development and just
Uh-huh.
enterprise contributions, but it didn't really satiate that fulfillment in me.
Hmm.
But when I learned more about hardware in that course, that digital logic course, it kind of sparked a little bit of an interesting thought process for me, where I could think about the hardware side as well as be on the intersection of software and hardware, because you can see how software is, you could see how it's actually executed on hardware.
Hmm.
You could see software is converted into instructions and
Yeah.
eventually gone through the pipelines of your hardware. And I think something that further reinforced that was graduate school. I took grad school, and I had a computer architecture course actually. And the computer architecture course was to design a 5-stage pipeline or a 5-stage CPU.
Wow.
Myths was the instruction set architecture, and I thought it was fascinating, and I poured so many hours trying to understand why do we have to program the hardware this way? Why do I have to have feedback loops? Why do I have to have certain XOR gates in certain locations? And
Yeah.
and I thought it was just very fascinating and very intriguing, and I kind of embraced that. Okay, you know what? I could see myself doing this for my career. Now it is a little bit of a niche space
Hmm.
because it's hardware descriptive languages, right? A lot of what I do on a day-to-day basis is system Verilog. In Europe, they use the VHDL most of the time. These are probably technologies that you've come across, and audience members in the podcast have heard about. So, and then I also use UVM. UVM is sort of a methodology that I also revolve around. That's universal verification methodology of how we actually verify our designs and whatnot. I'll get into more, obviously, more of my role in a little bit.
Awesome. I mean, that sounds so fascinating. And can you like just briefly describe any of the difference like between a software engineer role versus a hardware engineer role? What is the like the main difference? Yeah.
Totally. Fundamentally, I believe there's definitely a lot of commonalities. They're both tech-oriented roles, obviously. Software engineering is a little bit more about the abstract nature of programming, right? So a lot of the fundamental technologies used in software engineering roles are the higher level languages that we're accustomed to, right? We're very accustomed to Python and C++ and Java. These are all languages that we've come across in our career so far. And that what that is really a software descriptive language.
Yeah.
So it is a higher level language, but ultimately it's compiled or interpreted down to ones and zeros or binary.
It's not directly understood by the computer.
Exactly. It's not directly understood by our hardware or the computer, right? What our computer really understands is a combination of ones and zeros and matrices and so on.
Hmm.
But those ones and zeros are really a form of assembly language, a very, very low level,
Yeah.
low level language that the hardware interprets. The key difference there is software is, it's a program. It's a program that's being ran on or executed by your hardware elements.
Yeah.
Hardware engineering roles are a little bit different because we are using programming languages such
Okay.
as Systemlog and Verilog.
Hmm.
However, they're hardware descriptive languages. So when we write a certain block of code, we might be describing combinational logic or sequential logic.
Okay.
That's logic that's combinatorial, as logic that's based on AND gates, OR gates, XOR gates, etc.
Yes.
Whereas sequential, we have clock signals and reset signals in the picture, and synchronous natures and asynchronous natures. There's more of a timing element with respect to sequential logic.
Hmm.
And we write those blocks of code to describe our hardware. How does this block look? What is the purpose of my block? Is it an image decoder? Is it a instruction fetcher? Is it a algorithmic unit? Is it is it a program counter? Is it a memory? Is it a memory? Okay, great. How do I define my memory?
Yeah.
There's a lot of commonalities there because we still have to program at the end of the day, right? We still have to write code and
Yeah.
develop modules. Modules and hardware are pretty aligned to blocks of code and on the software side. So yeah, that's the main fundamental difference. It's just using a hardware descriptive language versus a software descriptive language. The HDL is then further uh, obviously synthesized into schematics and then the true hardware representation of it ultimately. So the hardware descriptive language is just a way to structurally represent our hardware. Yeah.
Absolutely. Fascinating. And is it like more of your particular role? Is it more hands-on? Because I know in software you're basically typing on the computer through a code editor or something like that, compiling it, running it. In hardware,
Oh,
it's like more hands-on where you like change things, NAND gates, OR gates with breadboards. I remember back in the day when I was in college,
right,
we were creating circuits and seeing
right,
how the circuit behaves and is it true or false and creating
right.
truth tables and all
Yep.
that stuff. And then there was a particular course I remember where there's a complete computer you create with the help of a single NAND gate, a NAND 2, or you might recall that course. It's a pretty famous one on the internet, and if I find it, I'll add it in the description. But yeah, I just wanted to know how is the
Amazing.
difference between both of them, like in terms of physical and hands-on as compared to typing or a simulator base. Yeah.
Totally. Yeah. I think yeah, I mean, it takes me back to memory lane of what you're sharing with truth tables and Boolean logic and experiments in the lab and breadboards and prototyping and whatnot. Uh, in terms of practicality, hardware engineers actually have a pretty wide spectrum. So my role in particular, believe it or not, is probably 95%, 98% of the time it's all simulation based. It's all remote because what we're doing is we're on the pre-silicon or pre-hardware phase of hardware development. Pre-silicon, they call it.
Okay.
Uh, Pre-silicon is where all the brain work goes in, the architecture of the hardware, the actual design of the hardware. That's where it's the gate representations,
All right.
and and then you've got the verification side. The verification side and the modeling side is where I've I've spent a great deal on in my career so far. I think it's pretty unique because you have to understand the hardware, you have to model the hardware in certain languages as well. You have to predict the outputs of the hardware,
Mm-hmm.
and you have to make sure that it behaves according to the design specifications or the architecture specifications. So I think there's a whole lot of value in that role because it's gratifying for when you come across and say, okay, you know what, I see a problem in the design.
Okay.
It's not behaving correctly. I can see in the waveform is just a list of signals and inputs and outputs and whatnot. You could see exactly why
Mm-hmm.
the output is not behaving as it should. So there's sort of like a gratifying component to that. However, there's also a phase called post-silicon. So pre-silicon, we're doing all the upfront work.
Mm-hmm.
Then once we're finished that cycle, we send it out to the fabrication facility, right? We send out our schematics, our blueprints, and GDS files they call it. Those are the lingo on that side.
Okay.
That's a stage called physical design. That's sort of the back end stage of the hardware development. After the fabrication facility fabricates so many of them, the
Yeah.
chips, wafers, which has thousands and thousands of our chips. Then we take cross sections, obviously, and we take individual chips. Then we put it on our test boards. Our test boards could be really, really, really large, PCBs, printed circuit boards, and whatnot. Then we verify and we bring up the chip. We have to provide power. We have to provide resets. We have to hook up logic analyzers. We have to hook up monitoring systems to this chip to see, okay, is it behaving accordingly? So there's the post silicon phase is a lot of hands-on, on-site practical work, and it's very pressure intensive as well. When it's tape out time, which is just before we finish the pre-silicon phase, and after when the chip comes back, it's a very, very busy, busy pressure sensitive time because everyone wants to know, is it working? Is it working? So
Awesome. Awesome. It's a mix of both, so pre-silicon and post-silicon, and you can see that so many simulation
right,
softwares have been adopted where you can just like test
right,
out your logic or test out your design before the actual production of the particular
exactly,
hardware. Uh,
exactly, exactly.
well, it's amazing. Uh, Going back to a little earlier, before all of this, your college experience,
Mhm.
and any of your impactful projects or internships, looking for like just our audience
Yeah,
who are like college grads or fresh grads or just doing their internships if they're looking for big companies. What were
yeah,
you doing that time that was a little different, maybe what you were looking at, and how are you trying
for
to
sure.
get or create different projects and improve your profile and resume for these other companies?
For sure, for sure. Yeah, I think this question is, something that a lot of fresh college grads have in mind, or even before graduating, and even after graduating. It's always good to practice certain things that you can distinguish amongst yourself to the next candidate, right?
Hmm.
I've done a couple presentations with graduate students from UT Austin who come on site to Microsoft actually to have these sessions, as well as I've gone to Texas A&M, fortunately and luckily, to share some of these insights. So what I would really emphasize on is always focus on your craft, always work on improving your understanding of the craft. If it's system Verilog, Verilog, if it's the hardware side of things, really showcase that through maybe an EDA playground exercise that you've been trying to solve or work on or understand. Or if it's on the software side of things, you could say, you've solved specific problems on lead code, or you engage in Stack Overflow posts and so on. It's really showcasing that passion, showcasing that craft,
Right.
and you want to compile these sort of contributions and whatnot. And what I would actually do is I would walk around with a little portfolio. Imagine an artist, a portfolio, like a photographer or a painter or whatnot. They're going to walk around with uh,
Sample
with their
designs. Yeah.
exactly sample designs, sample illustrations, and samples of their art. So that's what I would do. But on the analogy here is that I would walk around with, okay, this project is something that I've worked on and that I feel passionate about. I built a counter in Cadence, or I worked on this 5-stage pipeline,
Yeah.
and I would showcase exactly which software I was using, blocks of code that I would write in hardware.
Hmm.
These are sample output logs and whatnot. So I would really organize that. It would take time, obviously. I
Yeah.
would organize that into a little chapters or various pages and whatnot. I would walk around that with that as a portfolio.
Yeah.
And I found that was a great way to engage with employers, whether it be at job career fairs, whether it be reaching out to and maybe cold calls or LinkedIn reach outs and so on.
Yeah.
I think the outreach is so amazing these days, because there's there's traffic on LinkedIn, there's traffic on all these online avenues and portals.
Yeah.
But back in the day when I was trying to get a job in 2014 and 2016, I just focused on showcasing that passion, really spending time on that portfolio.
Yeah.
And then I would also strategize. So what I would do is I would study with specific books, right? So there's obviously the cracking the code interview books.
Very
There's
famous. Yeah.
very super famous. You have to kind of know that pretty well to be a software developer or an engineer. On the hardware side of things, there's this great book. It's a green book. I forget the name of the author, but I have it. It's on Amazon. It's called Cracking the Verification Interview, which is very, very similar.
Hmm.
Even though it's called verification, a lot of the concepts used in that book are like, it's the full spectrum. You have the architecture, you have the design, you have understanding of why certain pieces of logic are the way they are. You learn how
Amazing.
flip-flops are constructed. You learn how you know
Transistors
CPUs.
work. Yeah.
Exactly. You see a little bit of everything, and that book was essential in my training and my understanding of preparing for interviews and whatnot. But the way that I was able to distinguish myself was really with that portfolio.
Amazing. And regarding your, let's say, Microsoft interview, how was the
Yep.
process like for some hardware role? Because we're familiar with software roles. There's like technical interviews, behavioral interviews, and where in technical interviews you have coding rounds. You might have
Right.
3 rounds or something like that. But how is a
Right.
hardware interview conducted?
Yeah, it's a great question, because I used to uh, I used to perform software interviews back then as well as an internship, or during my internships, I should say. And I found that there was commonality between the hardware interviews, but hardware, they can kind of ask you a wide variety of questions. Which I noticed, they can even ask you some software related questions in
Wow.
your interviews. I interviewed back in fall of 2019, and it was a phone interview first.
Hmm.
First, they did about an hour technical screening. It was some screen share. It was like, I think it was Codility or Code Paste, or one of those online tools where you have to code and they can obviously see the updates on their end. It's live, it's visible.
Right.
Uh, and it was a game of, I remember it was a game of, obviously not to spend too much time on this one, but it was a game of Snake that had to be modeled in software. That's what they asked me. The game Snake, where you start off, it has to eat apples and you can move left and right and up and down.
Very
And
famous on Nokia. Yeah.
exactly, exactly. Very famous on Nokia and the old school. I'm sure people from the 70s and 80s would resonate with that. And they asked, what kind of data structures would you use? And
Oh, wow.
it was cool because by that point I had an interview strategy book that I was compiling based on all the interviews that I've conducted up until that point on various companies and so on. And
Hmm.
I would document that in my Google Drive, and I would prepare for that. So I had an idea of how to approach that problem, and that's an example of data structures and algorithms related question. That's what they asked me first on, and then they asked me another system Verilog constraint question, which is a little bit system Verilog specific. I mean, it's system Verilog. It's still very it has components of object orientedness in it,
Hmm.
apart from its hardware modeling side. What I thought was, okay, they can ask literally such a wide variety, so it's kind of crazy. But then on site, call me about a week or two later, it's still the same process.
Right.
4 to 6 reviewers. I think I had about 5 or 6, each one 45 minutes, few minutes, break in between. They asked me everything from sorting questions to how does a CPU work,
Okay.
what are structural hazards, what are different types of hazards. Then they asked me just system Verilog and verification concepts and questions. Yep.
Are they also like particular in operating system questions like what's a deadlock, and
Yeah.
CPU related stuff, and those
Right.
classical operating system Linux style questions, how to kill a child and stuff like that.
Yeah, yeah, yeah. Forks and killing and all that. And no, thankfully, operating systems and compilers was not really within the radar or realm of what I was asked. So that actually is a good point that you raise. That's a key distinguisher between maybe a software engineering
Right.
interview versus a hardware engineering interview. Compilers and operating systems, classic questions. I don't think I was ever asked that in the various places that I've interviewed at in my life. But they did heavily ask about system Verilog and Verilog related questions. Representations of multiplexers
Okay.
and gates and things like that, and just even visualizing and drawing, like, okay, I have a block of code. Can you draw what the equivalent hardware would look like?
Oh, wow.
So that was important, to really understanding non-blocking, blocking statements in Verilog, to understand, the gate representations, and even knowing just standard Boolean logic,
Hmm.
Boolean simplifications as well.
Okay.
So all sorts of techniques.
You've described a lot of technical skills, and is there any particular like soft skills to master as well, to be, good
Yeah,
at this role?
yeah. Right out of the gate, a lot of fresh grads, me included, obviously have this fear of trying to match up to the standard of perfection, or the standard of what it is to be in the tech industry, right?
Yeah.
We have obviously everyone wants to achieve high, everyone wants to do good for themselves. I think at the end of the day, you have to try and be organic.
Yeah.
You have to be honest. You have to defend the claims on the resume,
Hmm.
and it's always important to speak things through. It's okay to make mistakes. I genuinely mean it.
Yeah.
Everyone's made mistakes, and It's okay to make mistakes, but it's really important to circle back and share about that,
Yeah.
saying that here, this is what I learned from that mistake, or this is what I learned from that, phase. So a lot of the soft skills that they'll look at is, how do you bounce back from
A failure.
given like a failure, exactly. A certain piece of code is not compiling, or some deadline was not reached, or something out of the blue happened. A teammate,
Hmm.
when zero dark 30 on you, type of thing. All kinds of things come about. And I think just, having strong communication skills, that doesn't come, automatically. Obviously, that's acquired through lots of experience, and it's always refined, at all stages of our life, of course.
Yeah.
I think the soft skills is important in addition to the problem solving skills.
Hmm.
Having the patience to understand the question, and this that way they can gauge your sense of collaboration, because collaboration in our world is, it's hard to kind of quantify, right? You
Hmm.
can't quantify that. That's why it's a soft skill. Like how is this potential new teammate going to be working with you? How do you live problem solve this on the board?
Hmm.
Breathing, practicing, mindfulness,
Hmm.
and just trying to be even keeled is important in approaching interviews. But those are some of the, soft skills, and just having an aptitude to just say that, you want to work on any problem, small or big, and you want
Yeah.
to learn as much as possible.
Yeah. Being very hungry for, learning and, that kind of appetite you need. That
Right.
does help out, for you to stand out from an ocean of other candidates. Um,
For sure. For sure.
and these
For sure.
days, you can check how heavily people are being more inclined towards computer science and these type of
Right.
degrees relevant to CS and stuff. And
Absolutely.
have you think the advent and the start of AI and how it's been so reliant on big companies and it's been creating
Yeah.
major impacts on, let's suppose, things that have been the things that used to take weeks to get done, you can do in, hours. So is that also something vital to have a skill set, how to use AI and how is it being impacted on the hardware side?
Totally. Totally. You know, AI is such a mammoth of a topic. It's such a,
Yeah.
enormous beast. Modernization of technology, and so many people these days are learning how do we contribute to the businesses of AI, and just, development of AI. And that's why these big companies like Amazon, Meta, Google, Microsoft, just to name a few, Nvidia, of course, AMD, etc. They they're really focusing on this sort of wave to empower and to accelerate things. Like you said, what we used to take weeks now takes just a matter of a few seconds, right? You can go on these different natural language processing, tools, and you can provide such unique prompts, and you can solve your problems in seconds. It's crazy. What
Right.
used to take, I have so many examples that I can think of. I mean, even within the last hour, I was using ChatGPT with my barber at the haircut, and I was trying to help him solve a problem. And he didn't, he spoke Spanish, I spoke English,
Wow.
and it was just crazy how it's really changing the sheer fabric of society, of how we interact, of how we are gaining answers. It's just examples of empowerment. I think it is important to understand some of these high level definitions of AI. I don't think anyone really needs an amazing nitty gritty understanding of it, unless you obviously specialize in that field. If you're an AI scientist, if you're a data scientist, if you are studying in AI for your graduate degrees, or specializing in undergrad, etc., then you guys will be way ahead
Hmm.
in terms of that topic. From my end, since I work on the acceleration side of things, yeah, well, there's some high level criteria parameters that I have to be aware of from a qualification standpoint of, okay, how does our machine accelerator compare with Google's TPUs,
Yeah.
uh, or how does it compare with our NVIDIA H100s, or whatever the case may be.
Hmm.
Those are all those are all public knowledge, obviously. So pure discretion. I'm not sharing anything that's too sensitive here. Those are all public knowledge. Those things I have to be aware of as
Right.
a hardware engineer. And then I have to be aware of um, um, how do we see our software programs or our AI workloads being run on our hardware.
Hmm.
We have really good software, hardware, co-design type of mindset.
Yeah.
We know how a program could run on our accelerator, right? Then we have the different blocks of our accelerator. We have memories, we have compute cores, we have things of that nature, and that way we have a clear picture of, okay, this is what Microsoft is doing, and then I have to invest time into understanding how Microsoft is doing things. But at the end of the day, I try to make it generic, because from our end, from the hardware end, it's
Yeah.
really just a flow of bits, right? It's just a bit stream. It's all binary, and it's just some data bus, some protocols, some AXI, some specialized protocols, APBs, and whatnot. That's why I kind of do most of the problem solving on a day-to-day basis on my end. If I was working a little bit on a higher tier, maybe not pre-silicon or post-silicon, maybe I was working on the AI program management of this chip, then I would have to be aware of maybe more AI-centric parameters, or how do we really quantify how well this chip is going to
Right.
perform for our AI workloads from an inferencing standpoint or training standpoint and so on. But yeah, I mean, I think it is great that people are taking these degrees and certificates for AI, and they're able to do it remotely, and you can get it on Udemy, you can find it on LinkedIn. They give you all the basics. It all seems kind of abstract, but it is useful knowledge. And there's actually a really great documentary that I want to recommend. It's called The Age of AI. The Age of AI. It's on YouTube.
Okay.
It's Robert Downey Jr., Iron Man from the Marvel world. He narrates it, and it's such a good documentary, because it talks about the human impact and the human element of AI.
Wow. Amazing. And so that means like there is the involvement of AI in the field of hardware, and how
Yeah.
you're closely working with it. And
Yeah.
so it's here to stay and here to help the humans, do better work, faster work.
Sure.
And so, yeah, definitely recommend that. Now pointing to another topic, like I've seen that on your profile, you pursued a master's degree.
Hmm.
And some people, like during their industry or corporate life, they tend to dive into the industry more. And what do you prefer? Is there an option to also go for a master's, or just dive into the industry and work your way up to the ladders of, positions and roles, in a particular company?
Yeah, I think when it comes to, sorry for that, when it comes to graduate degrees, I highly do advocate for it. The reason is because, as you mentioned before, it's hard to kind of stand out just from an educational standpoint these days. And in terms of really, really getting that enriched learning experience, I think a master's really aids in that. I don't think I would have been as aware of my field without the masters. Finishing the undergrad was, sure, it was the basics. I
Yeah.
also did an internship, fortunately, at Cisco. That's how I kind of got the start of the kickstarting that process of learning. But graduate school is where I really spent a lot of time by myself and investing
Hmm.
in in learning about hardware and learning about computer architecture and learning about Verilog. And those 2 years gave me that opportunity to strengthen my um, understanding of the field, because I had coursework, which was 6 courses I had to finish in those 2 years, as well as there was a research project.
Well,
The research project is basically that's what we write the thesis on. So my master's was thesis based plus course based, which was super valuable in my opinion. Even if it's course based, it's valuable. If it's a year or two now, doing things where you're working and pursuing graduate or advanced degrees, that's great.
yeah.
That is demanding. That is very, very demanding on a day-to-day basis, and that's going to take maybe a little bit more time to accomplish, but to each their own. But the key value that advanced education really brings is just enriched learning experience, right? if you do have a thesis-based master's, you get to work with a supervisor, you get to work with maybe a research team, you get to come up with so many questions, but maybe only a few answers.
Hmm.
I'm obviously saying it in a high level sense, but there's a unique challenge and a unique uh, learning experience when it comes to grad school, and I couldn't have been more grateful. There's all kinds of challenges that may come in the way, right? Maybe
Yeah.
teammates who are not cooperative, or maybe teammates who are not helpful,
Yeah.
or maybe imposter syndrome is also a very key thing that all of us may experience to some degree in this cutthroat tech industry. But
Yeah.
at the end of the day, you just have to try and be organic, and just focus on the craft,
The
enjoy
process.
learning,
Yeah.
enjoy the process, and yeah, just I would say if the opportunity presents itself, masters are really really valuable for the long run. Now, continuing that advanced education to PhDs,
Yeah.
that's a different story. That's a different animal.
Yeah.
Now, that's
That's
one of that academia and whatnot. That is to each their own.
in terms of balancing both things. How were you being able to manage your, masters along with, I think you were working within a company as well. So
Hmm.
how do people do that these days?
Right. Well, fortunately, so I went from undergrad and I went into grad school actually directly, and I didn't work immediately out of the gate after undergrad. I kind of took the time to really hone in on my learning process for the hardware field.
Yeah.
So I was grateful that those 2 years gave me that amount of time and luxury, because I focused on the coursework, the thesis, and oh yeah, the thesis based masters. There is some school funding that is given, which is helpful to sustain those 2 years, of course. And
Amazing.
then I also worked as a teaching assistant and a sessional lab instructor as supplemental sources of income. But ultimately, uh, I don't think I would have been able to devote that much time to complete that master's in 2 years if I was working full time.
Okay.
Uh, it's very difficult. I've had friends who are able to complete a master's in about 3 or 4 years. Plus, they're working full time in parallel. Some take even 5 years to finish a master's.
Wow.
And that's a pretty long time.
Yeah.
Is that it's tough to balance. It's definitely a slower process.
Hmm.
But I do advocate, if people have the opportunity, to just hone in on completing the masters immediately. But of course, it may not work for everyone.
Definitely.
But if you are in the stage where you're doing it in parallel, maybe your company is helping with the masters, right,
Right.
for tuition or stipend or MBAs or whatnot,
Yeah.
then it's just a matter of time management. Pace yourself, and obviously some days you're going to be stretched. There are some other days where you might not be as stretched, and really carve out that time to um, shuffle the priorities and whatnot. But of course, to each their own, and everyone's life circumstances. So
It sounds amazing. Let's go at the life at Microsoft and industry
cool.
insights. So, how does a day in the life on Microsoft's AI Silicon team look like for you?
That's funny. I have a slide with in regards to the presentations I've been doing here and there,
Yeah.
and I'm almost tempted to let's see if I can find that slide.
Oh, wow.
Uh, and then if I could find that slide, I will literally just pretty sure you could just do snippet, right? Snippet,
Sure.
drop into this. So let's see here. I will share it right now. Just a few seconds.
No problem.
Uh, um, I think I found it. Yep.
So you're presenting?
I'm actually not presenting. I could present, or I could
You,
share just a
yeah.
snippet. What would you prefer?
So you can just explain, and
Yeah.
then we'll just talk about how does it look like on a day-to-day
Yeah.
basis. Yeah.
Yeah. Totally. Totally. I could also do a screen share. Is that going to be? Is
I think
that fine in the
I think it's
podcast? Yeah.
yeah, it's definitely
Yeah.
fine. Yeah, you can go ahead.
Okay. So where's the screen? Is it right over here? Share screen. Um, should be good. Are you able to see?
Yep.
Okay, awesome. Yeah, I mean, it's a little bit, cliche, a little bit cheesy, but on site, if I'm on site, they have amazing facilities and food on site. So, it's commute plus breakfast, and then I try to maximize the mornings, whether I'm at home or on site.
Right.
Uh, Lunchtime, culinary adventure, obviously another. These tech companies, they just shower you with all kinds of good eating and whatnot. And the Mountain View campus in Microsoft, or Microsoft, I should say, Mountain View is in Bay Area, just in between San Jose and San Francisco. That's the headquarters of Silicon Valley, for most of the hardware folks.
Amazing.
So you would go there and you'd just be showered with so many different stations, so many food options. They have Indian food, they have like Thai food, they have everything. It's amazing.
Hmm.
It's really it really feels like an airport. You know what I mean?
Wow.
And, and then after that, it's usually a lot of meetings around the clock. Some early morning meetings as well, because we have teams overseas.
Right.
A lot of the meetings are a lot of just collaborations and making key decisions and how we solve certain problems, or how we solve certain dilemmas, and keep track of that with our different reporting systems. Obviously, if I'm at home, a lot of it is screen share collaboration and whatnot.
Right. Through Microsoft Teams, of course.
Of
Yeah.
course, none other. It would be criminal to use anything else. But
Yeah. Yeah.
uh, I'll try to take some breaks around the clock. If I'm at home, maybe I'll tune into a little bit of some prayer, some watching some YouTube, etc. here and there. Make some food, etc. And then final stretch is just continue to work. Just take a look at what tasks are on my plate. I usually keep a tasks list or to-do list, and
Right.
then different different sort of what do they call it, like streams are really the focus of a certain week or a focus of a given month,
Hmm.
and I can see how much we've accomplished of that task. And then our life cycle for design and verification, it could be 6 months, a year and a half, etc. And then we have certain milestones along that cycle, and we have different criteria and metrics to see how well we're doing within that given milestone. We have, like, a 10% milestone, a 50% milestone, 80% milestone, and then obviously the full closure. So
Hmm.
so those involve lots of things. Like, it involves looking at certain test completions, certain regression health. Regression is just how well those tests are running in our automated regressions, how well how much of the design has been implemented by the design team, or the design is also referred to as RTL, basically the register transfer level or register transfer layer
Hmm.
that's implemented in the Verilog. And then so it's some firefighting might happen. Some teammate might run into a given problem. For example, their pull request is not merging with main because of some failure in our
Right.
qualification process, and then we have to collaborate and see, okay, what's the given problem. Is it some test failure? Is it some build error? Is it something different? Is it some infrastructure related thing from Microsoft,
Right.
and so on.
Yeah, of course. And in terms of like culture and collaboration at Microsoft, how's that over there?
Yeah, culture, collaboration, like any big tech company, your immediate team and your manager, that's the important relations that you want to emphasize on. I'm just going to stop sharing here just to
Yeah.
make sure that I'm um, and the culture of a company is based on so many things, right? It's based on leadership, it's based on technology roadmap, technology, how it's conveyed as what's the company's course of action? What do they want to focus on? What type of hardware do they really want to excel at?
Right.
How are they pouring their resources in? And these are decisions that are way beyond a given individual, right? It's usually at the upper level. It's usually discussions with leadership and CTOs and so on. So we just simply try and drive that direction forward.
Yeah.
And the culture, it's obviously it's a fast-paced environment. People do want to find answers quick. People want to collaborate and resolve problems as soon as possible. And we have to be very adaptable to different scheduling, different timeline changes, and so on. So the culture has changed since I joined, no doubt. And I think any company nowadays, any tech company nowadays, feels that sort of intensity.
Okay.
But at the same time, I think there's great opportunities to learn. There's great opportunities to work on a variety of problems, whether they're small or big. And there's great ways to contribute, to really, add value to the team.
Mm-hmm.
And that it has been sort of my motto since I've joined, that we work on individual growth, we work on the team-wide growth,
Yeah.
was we leverage what is existing at Microsoft and we try to add additional layers on it. So those three facets is what Microsoft tries to highlight in terms of their work culture. And in terms of the company culture, yeah. I mean, they do try and care for your well-being. They do
Mm.
try to look out, and they have good resources in place. So yeah, it's all to see how that meshes in from a given person and a company circumstances. So it's yeah, I would say it's overall pretty good. It's pretty reasonable. It's pretty good in the overall landscape of things. But that's, of course, my 2 cents. Someone else may disagree, and that's fine.
Yeah, that's totally fine, and that's what makes us humans. We all have different perceptions, and I love that.
Right.
So,
Right.
fun and personality, career advice style questions. I'm just gonna have a small rapid fire round. It's just we're
Let's
almost
do it.
ending the podcast, so it's been
So
great
good.
so far. So, what was your favorite tech gadget of all time?
Tech gadget. I mean, something for entertainment or just
It could be anything.
anything.
Yeah.
Could be anything. Oh man, I favorite tech gadget. I mean, I don't know why I'm taking so long on this one, but a couple of things come to mind. I mean, I know it's going to be a little bit. It feels like I'm betraying Microsoft, but no, I'm not. The iPod, the original iPod, I thought was just so fascinating. The scroll,
Oh yeah.
the circular scroll. It was just, I had that in like 2007, 2009, and I'm born in the 90s, right, in the early 90s, so I feel like I'm maybe a little bit older than most of the new generation techies. So that gives me a sense of nostalgia because I still listen to so many cool songs on the in public commutes and whatnot. And the iPod is just it was just so ingrained in my mind. Um,
That was
and
revolutionary, especially with those headphones what they came with white ones.
exactly
Yeah.
the white ones,
The
exactly
wired ones. Yeah.
the wired ones, exactly. It's just like thick, just wraps around. I would listen to that literally on the subway, on the bus, while going to high school in Toronto. So a lot of nostalgia there. So yeah, the iPod for sure.
And I recall I did have an iPod 6 Touch, so they kind of like upgraded till the iPod 7, I believe. So now they kind of stopped them. Uh,
Uh,
and they had it was like almost turning into an iPhone, the iPod actually. They had the
right.
whole
A lot.
app store, they had the whole camera, they had the whole gallery and everything.
Oh, me.
But the only thing that was restricted was the SIM. So
Oh my gosh. Everything else but the cellular. Jeez, it's like a
yeah.
mini phone basically. Yeah.
Basically,
Yeah,
yeah, and it was pretty popular. I mean, yeah, one of the iconic gadgets of all time.
for
Um,
sure.
Toughest bug you've ever faced?
Ooh, that's a tough one, man. That's a tough one.
Yeah, it was actually the toughest to bug, so tough.
Toughest bug. I mean, there's so many that has been, I've had the fortune of contributing to find the solution of, and then the last 5.5 years so far here.
Yeah,
I would say obviously the most of my critical contributions have been in this company. I've worked at other companies before, by the way,
yeah.
but I'm just mentioning Microsoft. I think something recently I was looking at a gate level simulation. GLS is what it's short form for. So gate level simulation is when the hardware is structurally converted to gate level representation. So a lot of the gates,
Mm-hmm.
uh, and gates and OR gates, and
Oh yeah.
logic and that. And then that is what is essentially simulated, the gate level representation. So you have additional timing in place. You have got like setup time, hold times for your flip flops or your and whatnot. You've got obviously inverters and everything of that in place. So with gate level simulation, it is a different beast. It's a different animal because you're pointing to technology libraries, you're pointing to a technology standard,
Mm-hmm.
timing, and you're also running into some optimizations that are done to maybe speed up the gate level
Yeah.
net list simulation.
Mm-hmm.
And I didn't have necessarily a whole lot of experience in this realm, and I was tasked to solve something, a series of problems within the last I think 6 months or so.
Yeah.
And I was like scratching my head. I was like, what the heck? So it was a lot of collaboration with our vendor company and overseas calls and whatnot. And I was running into bugs with with our gate level net list where it was like having some different timestamp related mismatches, nanosecond, picosecond, things like that.
Mm-hmm.
Uh, there was like a precision loss.
Yeah.
There was different switches that were not in place that was correct. And then this eventually led to me discovering some hardware related issues in that were discoverable. But yeah, that's what I could probably refer to. Um, Other bugs that I've come across, uh, you know, uh, specific to the features of the design. Of course, it entails a lot of fixes and entails a lot of it's really a combination of, okay, is the design being programmed correctly?
Mm-hmm.
Why is the output not matching or behaving as predicted by the expected output? That's really where we have to kind of fill in that gap. I remember I was working on a given feature of this interconnect, IP interconnect, just like a PCIe Express type of interconnect, and we had this additional feature at the outbound or target of that interconnect, and the prediction modeling was very, very challenging for that. So I'd have to use some advanced constructs in System Verilog, but luckily it worked. It took about a week and a half to solve. So
Well,
no,
your thoughts on mentorship and giving back?
super valuable. We live in the time where we had COVID and the social structure of how people communicate with one another. It's changed, right? It's not what it used to be. Back in the day, it was more classic, from learning from peers and colleagues and in the workplace and in on site at school and whatnot. Nowadays, it's just conversations like this,
Yeah.
live streams and screen shares and collaboration and whatnot. I
Mm-hmm.
always feel that it's important to share what you know, to share what you've come across.
Yeah.
And I think companies like Microsoft really, really value that.
Mm-hmm.
They really give a lot of recognition and highlight to people that leverage existing solutions, but you add to the value of those, and in addition you strengthen the team, right? You strengthen the team's foundation and knowledge and overall their ability and their capacity as well. So we're all going to have some years of experience under our belt. It's
Yeah.
important to approach interns, approach juniors, and
Mm-hmm.
really share what we know, and really try to raise their level of confidence and understanding as well. And it's okay, there might be some things that are not immediately solved or understood in the beginning and whatnot, but I think it's valuable to sustain our good habits and good relation in our careers. uh, because yeah, in these tech jobs you can't do things individually anymore. I don't think so, at least. I do think that it's important to train the next generation as well.
Yeah.
Carry forward, basically, pay it forward.
Absolutely. Final advice to fresh grads in under a minute.
Fresh grads, you know, Obviously, I want to sound too cheesy, but always focus. Obviously, always focus on your craft. Cherish every opportunity, whether it's small or large. Network, connect, aim to cooperate. Hold accountability. Defend your claims, and approach things with kindness. Don't be too cutthroat and know it all type of person.
Hmm.
Be kind and really focus on the growth mindset.
Hmm.
Growing always. That's what Microsoft values, by the way. Growth mindset. Learn it all. That's learn as much as you can,
Okay.
and incorporate that into your work. Experience is obviously the best teacher of life. So the more and more experience we have, it'll season us and it'll kind of maintain a good level of confidence. Yeah, personal projects as well. Prototypes, FPGAs. If you play around with Raspberry Pis for home projects and things like that, that's amazing. But yeah, just listen, learn, and take any kind of action.
Sakib, this was been an absolute amazing conversation with you. Thank you so much for sharing your story, insights, and honest advice. For all the listeners out there, whether they're a college student, a recent grad, or someone who's just curious about the world of AI hardware and silicon design, I hope you're taking away some valuable insights and how to start paving your way through this endless amount of learning opportunity and experience. If you want to connect with Sakib, I'll leave his LinkedIn link on under the description. You can always go ahead and reach him out. And yeah, thank you. Stay curious and always learn to grow.
Absolutely. Thanks sincerely for having me, Harris. Great to meet you. Great to share insights and knowledge about tech and life so far. Wish you all the best. All the best to the audience members as well. Feel free to reach out through LinkedIn or the other means and
Yeah,
stay in touch. All the best on the podcast. Keep it up. Great work.
thank you.